This video, I'm going to work through the Unit 2 touchstone from CTLS so that you can see how each question should have been worked out. All right, first one, student constructs an image with dilating, center is O, scale factor is 3. So what is going to describe the image? All right, so if we think about this, let's say that's O and here's our segment. If we're going to dilate that, it's going to become 3 times bigger and 3 times further away. So it's going to end up being something like this. So what's going to end up happening is it's going to be parallel to the original. All right, AB is 2.4. It's dilated by 3. So what's the new length? So 2.4 times 3. A right triangle has a hypotenuse of 5 and a leg of 4. It's dilated by a scale factor of 2, so what's the smallest side? So first thing that we need to do is use Pythagorean theorem to figure out the smallest side, which is going to be 3. 3, 4, 5 is a Pythagorean triple, but if you go through Pythagorean theorem, 25 squared minus 16, or sorry, 25 minus 16 would be 9, so that side is 3. We're going to scale it by 2, so the smallest side is 6. All right, number 4, what is the scale factor? So I taught you to just use new over original to get the scale factor. So the one with the primes is going to be the new one. So this side is 35 and it matches up with the original 20. Those can be reduced by 5, so 7 over 4. All right, NOP has side lengths of 5, 7, and 9. There's a similar triangle, so what could be the side length? So we're looking for multiples of 5, 7, and 9. So let's start with this one. If we multiply by 3, that one doesn't work. All right, so from here to here, this would be 1.5 times. This would be 1.5 times, and that would be 1.5 times. So there's our triangle, and the scale factor would be 3 over 2. All right, page 2. So looking at these, what is the scale factor to get x to be congruent with y? So again, if we use new over original, we want x to become y, so y is our new one. So just looking at a measurement, I can see that the radius of this is 3, and the radius of the original one is 4, so our scale factor is 3/4. Number 7, use the figure to answer the question. So what is the length of DF, which is this one right here? So I'm just going to use a proportion. 6 over 8 needs to match up with x over 12. So if we multiply diagonally, we can see that that piece is 9. All right, next up. So we have the similar right triangles. So we need to pick the triangle that is similar to triangle ABC. So what we need to pay attention to is this is short leg, long leg. So ABC, short leg, long leg. So ABD would be hypotenuse, long leg. ADB, so ADB would be short leg, long leg. So there we go. If we just show why these don't work, BCD would be hypotenuse, long leg. And then this one is the same triangle, so that wouldn't make sense. Number 9, BC is the mid-segment of ADE. So BC is 2x plus 4, and DE is 6x minus 12. So what we know about this is that this piece right here is half of that piece. So this segment right here, DE, is twice the length of BC. So BC is DE divided by 2. So this piece right here would be this length divided by 2. So if we just fill in what we know, BC is 2x plus 14. DE is 6x minus 12, but if we take half of it, that would be 3x minus 6. So it looks like x is 20. So find the length of BC. So if x is 20, this is going to be 54. All right, number 10. We have this triangle. We know the measurements and we know it's similar. It looks like the scale factor is 6. And the question is, what is the perimeter? Well, the perimeter of this one is 21. And this one is 6 times bigger. So its perimeter is going to be 126. All right, number 11. So what additional information do you need to prove by side angle side? All right, so we have those two sides are given. We know by reflexive that those two will be congruent. So it looks like for side angle side, we need angle BCA and DCA. So BCA and DCA. Number 12, how can we prove these two? Well, they're right triangles, so we can eliminate those, and we have hypotenuse legs. So now it looks like we just need to check the order. So ABC, so that's short leg hypotenuse. So short leg hypotenuse would be short leg hypotenuse JKL. So there you go. All right, Heather is 1.6 meters tall and casts a shadow of 3.5. A barn nearby has a shadow of 17. All right, so here's Heather. She is 1.6 and her shadow is 3.5. Then we have a barn that we don't know the height of the barn, but we know the shadow is 17.5. So I'm just going to set up proportions. So 1.6 to 3.5 is going to match up with the height of the barn and 17.5. So then if we grab the calculator, we're going to multiply 1.6 by 17.5 and divide that by 3.5, and we get 8. All right, next page. Okay, so given these points, all right, so we know that ABC is the original and DEF is the new one. So we need to figure out how did these points transform from there to there. So first up, if we just think of this as being our original XY, so this one would be 3, 1, and then it would change to be 1, negative 3, and then from there it would change to be 1, 3. So that is not what we ended up with, so we can eliminate that one. Here we start with 3, 1. It would change to be negative 3, 1, and then from there it's going to change to be 1, 3 again, so not that one. All right, translation is not going to get, it's obvious that we're either rotating or reflecting since our numbers are staying the same. So let's just check this one. So if we started with 3, 1, this would become negative 1, 3. If we started with negative 1, 3, this would become negative 1, negative 3, which is what we have. So there you go. Number 15, a pilot uses triangles to find the angle of elevation from the ground to her plane. So if she knows angle C, how can she find angle A? All right, so if we look at these two triangles, I can see those sides are congruent and these sides are congruent, and we know vertical angles are congruent, so that proves side angle side. And then from side angle side, we would know that angle C is going to be congruent to angle A using CP/CTC. So we have side angle side well, CPCTC is not going to come first. So we can eliminate those, and we don't have angle side angles. So there you go. Okay, number 16, E is the midpoint of these two segments. So if it's the midpoint of AC, that means those two pieces are congruent. And if it's the midpoint of BD, then those two pieces are congruent. And we know vertical angles are congruent, so we have side angle side. So there we go. All right, number 17. Use the figure to answer the questions. So, all right, so if we look at this, that's given. We know by reflexive property that this piece is congruent. We have right triangles, so this is hypotenuse leg right here. So it looks like we just need to match up the letters. So GJH. So GJH would be IJH. IJH. All right, number 18. Two lines intersect to form vertical angles. All right, so we have vertical angles right here. 1 and 3 are vertical, so that means that this one and this one are equal to each other. And then 2 and 4 are vertical, and we know this one is this. And then we have to figure out the X, the Y, and then the measurements. All right, so first off, we know that these two are equal to each other, so I'm going to start with that. So 20x plus 7 is equal to 5x plus 7y plus 49. And then I also know that together, these two, or these two, whichever way, I'm just going to go this way, these two add up to 180. So if we add these together, that would be 23x minus 2y plus 37, and those two add up to 180 degrees. So I can tell by these equations that I probably want to use elimination since I have two variables. So if we get all of this together, so this would become 15x minus 7y. If I bring that and that over there, and bringing the 7 over would be 42. And then this one, 23x minus 2y equals, so I need to bring this over here, which should be 143. So now I have systems of equations here. So we have two options. We can set it up as a system, or we could even look at just filling these in, but with calculator, I think system of equations is just fine. So I'm going to get the y's to cancel, so I'm going to multiply this line by -2 and this line by 7. So if I multiply this line by -2, that would be -30x plus 14y equals -84. And then if we multiply this one by 7, that would be 161x minus 14y equals, well, let me multiply that out, 1001. So combine those together, those are gone. So 161 minus 30. So move right in here if I can fit this in here easily. All right, so 161 x minus 30x is going to be 131x. So 131x. And then 1001 minus 84 is 917 divided by 131, so x is 7. So x is 7. There we go. Okay, two parallel lines and a transversal. All right, so two parallel lines and a transversal. 1 and 2 are same side interior, so I'm just going to say that's 1 and that's 2. 2 and 3 are vertical, which means 3 is there. 3 and 4 are alternate exterior, which means 4 has to be up there. So the relationship between 2 and 4 is corresponding. All right, number 20. So what is the measure of angle 1? And the hint is to draw a line here. All right, so if we draw this line right here, all right, now let's just focus on this right here. If this is 35, I know this piece right here is 35 degrees because that's corresponding angles. And then if we look at this one, if this is 130, I know this one right here is 130, which would make this one 50. So now I can see that angle 1 is 85. All right. Okay, let's see. Use the figure to answer the questions. All right, if these two angles are congruent, then I know those two sides are congruent. So it looks like x equals 15. So if x equals 15, then we can just fill it in, and the answer is 70. Okay, BC is right here, and XY. All right, so we can see by all these markings that these are mid-segments. So this piece right here is half of this piece. So XY is BC divided by 2. So looking at that, I don't really like those numbers there. So the other way that we can think about it is that if we had 2 XY pieces, that would equal 1 BC piece. So let's put those marks there. So I think I'd rather do that. So if I had 2 of the XY pieces, so 2 of these would be 4x minus 6, and that would equal 1 of these, which would be 3x minus 1. So it looks like x is 5. So the length of xy, so if x is 5, that looks like it's going to be 7. All right, this is another one with the mid segments here because they're all marked. Okay, AD is 5, so we know that one's 5, and we know that piece right there is 5. AT is 18, so if that's 18, that's 9, and then that one is 9. And then CT is 22, which makes that 11, that 11, and this one right here, 11. So the perimeter right here looks like 25. All right, surveyor is trying to measure across a pond. So this little triangle up here is similar to this large one right here. Triangle, okay, CD is 4, and CB is 12, so the whole thing is 12. We have that as 5 in the picture, and we're trying to figure out how far it is across the pond. So I'm thinking I'm just going to do a proportion here. So 4 over 5 is the small triangle, and that matches up with 12 over x. So 4x is 60, so that makes x 15. Okay, whatever this is, represented by A and B. Okay, so these are two galaxy systems, and they're the same distance from Earth. So that means that piece and that piece are congruent. What that tells me is that this angle and this angle is congruent. So if this is 115, that would make this one 65, which would make that one 65. So angle A is 65. Okay, ABCD is a parallelogram. Okay, so we're trying to prove that angle A and C and B. Okay, so first we start off with definition. Then they're saying ADB, ADB. So this angle right here is congruent to CBD, this angle right here. So why are those two congruent? Well, those are alternate interior angles. Okay, quadrilateral. All right, so here we go. So we have a quadrilateral. All right, let's go ahead and label it ABCD. All right, so AB and CD are congruent. BC and DA are congruent. Oh, and the diagonals are congruent. So that tells me that this is going to be a rectangle. So, it is not a square because we don't know that those four sides are the same. We just know. So it's not a square and it's not a square. Okay, here we go. It's not a square. We don't know that, oh, the diagonals aren't congruent. Never mind. So there we go. All right, ABCD, AB is congruent to DC, so those two sides are equal. And then AD, so those are congruent to those. Okay, so I'm going to think of it as a different way. I know that those two have to add up to 180. So if we look at these as parallel lines with transversal, those two have to add up to 180. The other thing we can do is add all four of them up to 360, but that would just be the same thing. So 2x plus 20 has to add up to 180. So that tells me that x is 80. So angle D is 80. All right. We did not do the constructions yet because those are require some tools. So we're going to skip those. Okay. So if PQR is congruent to XYZ, which statement is not true? All right. PR and XZ, excuse me, that's fine. YZ and QR is fine. RQ should be ZY, so that is not true. Okay, these have been done. Okay, so this is the original one, that's the new one. So new and original. All right, what is the scale factor? Okay, well, I'm just going to look. This side right here is 2. This side right here is 4. So remember, if we do new over original, the new one is 4, the original one is 2. So the scale factor is 2. So the scale factor is 2. All right. So what is the similarity ratio of the areas? Okay. So if you don't know this one, which does make sense, and I'll explain it in a second, we can just go through and find the area. So the area of a triangle is base times height divided by 2. So for this triangle, if we do 3 times 2 divided by 2, the small one is 3. If we do the large triangle, base times height would be 24, divided by 2 would be 12. So if we write a ratio from the pre-image to the image, that would be 3 over 12, which we would reduce to 1 over 4. So we can write it like that, or like that, or like that. All right, the other thing is if the scale factor is 2, that means this is 2 times larger, which means that if you think about the base and the height, if we have this triangle, which is base and height, and then we have this triangle, which is 2 times larger, when we go to find the areas of these, this is going to be base times height divided by 2. This one is going to be base times height divided by 2. So you can see that this one is going to be 4 times bigger than this one because we're multiplying by 2 here and here. All right, that takes care of it.